beyond the sky and into space. In this video, we would like to introduce you to some of JAXA's major projects. Satellites orbit our Earth and play an important role in our day-to-day lives. According to data acquired by the Greenhouse Gases Observing Satellite Ibuki GOSAT for 6 years, the average planet-wide carbon dioxide concentration among the increasingly warmer Earth's atmosphere was recorded at approximately 398 ppm in July 2015. If the rise continues at the present rate, the concentration is predicted to surpass 400 ppm by the end of 2016. Furthermore, Ibuki detected concentration increase related to the release of methane gas as a result of human activity. Hence, it has been recognized as a potentially useful monitoring and verification tool for the released amount of anthropogenic methane gas. For the Ibuki successor, GOSAT-2, we plan to install an even higher performance sensor that will allow more precise greenhouse gas observations. The Advanced Land Observing Satellite 2, Daiichi-2, ALOS-2, has been conducting observations to better understand the conditions at the time of disaster since its launch. Observation data acquired by the L-band synthetic aperture radar, PULSAR-2, is immediately supplied to the Geospatial Information Authority of Japan and related disaster prevention organizations for tectonic movement analysis. This data is utilized for the Nepal earthquake, the Hakone Owakudani bulging, continuing eruption warnings on Sakurajima Island, and other emergency observations. From astronomical observations to planetary exploration, various challenges await us within the wide scope of the space frontier. The asteroid explorer Hayabusa 2, which was launched by JAXA in December 2014, has performed an Earth swing-by and is now successfully heading towards its destination, the asteroid Ryugu. An Earth swing-by is a technique where an explorer is brought close to the Earth, and then the Earth's gravity and rotation are used to change the course and acceleration of the explorer. The Earth swing-by for Hayabusa 2 took place on December 3, 2015. The spacecraft's path was then carefully observed and analyzed until December 11th to confirm that the planned orbit had been precisely followed. Hayabusa 2 is scheduled to arrive at the asteroid Ryugu midway through 2018, where it will remain for around 18 months before returning to Earth at around the end of 2020. On December 7, 2015, the engines used for controlling the attitude of the Venus Climate Orbiter, Akatsuki, were fired as planned for 20 minutes, and the probe entered orbit around Venus. Measurement and calculation of Akatsuki's orbit have revealed that the probe is orbiting in the same direction as the rotation of Venus. This is the first Japanese planetary spacecraft to successfully enter the orbit with another planet. Plans to shift toward the regular Venus observations are set to start around April 2016. JAXA launched the X-ray astronomy satellite Hitomi on February 17, 2016. The Hitomi is expected to detect the X-rays and gamma rays emitted by high-temperature and high-energy regions such as black holes, supernovae remnants, and galaxy clusters, as well as to explain the origins of the universe and physical phenomena lurking within the universe. The Hitomi is a flagship X-ray astronomy mission developed through the participation of over 250 researchers from universities and research institutions around the world. Kibo aims at further revitalizing industrial activities, developing science technology, and acquiring space exploration technology for the future. Astronaut Kimiya Yui was aboard the International Space Station (ISS) for 142 days from June 23 to December 11, 2015, and conducted experiments in fields ranging from high-quality protein crystal growth to life science to material and physical science and space medicine. While tackling a variety of experimental and technical development themes, he also constructed mouse habitat unit and other new experimental environments. Yui also controlled the ISS robotic arm with the communication aid of astronaut Koichi Wakata on the ground to catch and detach the space station's transfer vehicle, Konotori 5. The Japanese Konotori Operational Control Team worked together to make the mission a success through the collective strength of Team Japan. With the reliable operation of Konotori, the high level of Japanese space technology was once again shown to the world. Following astronaut Yui, Japanese astronauts Takuya Onishi and Norishige Kanai are scheduled to take part in extended stays up on the ISS in 2016 and 2017 respectively. Utilizing the condition of microgravity without convection, high-quality protein crystals can be grown on the Japanese experiment module Kibo. Crystals grown in space are brought back to Earth followed by analysis. The resulting structural information is useful for the research and development of medicine and industrial enzymes. Through these experiments, the 3D structure of an enzyme essential to the growth of the bacteria that causes periodontal disease has been clarified in detail for the first time. For high-quality protein crystal growth experiments, JAXA is working hard to shorten the preparation time for the experiment by 3 months to match with the R&D cycle on the ground, and to technically develop and verify the high-quality crystallization of membrane proteins, which is in high demand by pharmaceutical manufacturers. For a new science discovery experiment, the Calorimetric Electron Telescope, or CALET, was transported to the ISS by Konotori 5 and installed on the exposed facility of the Japanese experiment module Kibo. Measuring the extremely high-energy cosmic rays at a tera-electron volt, we can expect new world-leading discoveries, such as the propagation and acceleration mechanisms of high-energy cosmic rays, still unexplained even now, 100 years on since the discovery of cosmic rays, as well as the search for dark matter and more. During astronaut Yui's stay on the ISS, 2 microsatellites, one developed by the University of Brasilia and the other of the Chiba Institute of Technology for observing meteors, were successfully deployed from Kibo. More opportunities for microsatellite deployment from Kibo are scheduled to make people feel familiar to space utilization. In September 2015, JAXA and the United Nations Office for Outer Space Affairs agreed to cooperate in providing opportunities to deploy microsatellites from Kibo. Through the collaboration, JAXA hopes to contribute to the expanded utilization of outer space, along with developing countries, for the advancement of their space technologies. Reliable launch vehicles and cargo transporters that have excellent technical capabilities are essential in linking the Earth with space. JAXA is conducting the H-2A upgrade project to develop and improve the highly reliable H-2A launch vehicle. The launch of the H-2A launch vehicle number 29 incorporated the development results of improved geostationary satellite launch capability and was successful in reducing the satellite's burden to reach its geostationary orbit. Various modifications were made to improve the design of the second stage and facilitate longer flying time, including measures to reduce evaporation of the propellant and to maintain the engines at an optimum temperature. The H-2A upgrade will further improve our international competitiveness, and the results will be passed on to the development of the H-3 launch vehicle. The next-generation mainstay launch vehicle has been named the H-3 launch vehicle. This new model, which is to succeed the current H-2A and H-2B launch vehicles, will be Japan's main space transportation starting in the 2020s. Through improving the ease of use from prior launch vehicles and realizing high reliability and low cost, JAXA is aiming for a strong position among international competition. The development of the enhanced Epsilon launch vehicle includes increasing launch capabilities and expanding payload usable volume. The second stage motor of the enhanced Epsilon has been scaled up from the previous model in order to improve capabilities. The motor underwent vacuum static firing tests at the Noshiro Rocket Testing Center in December of 2015, and performance data was obtained to validate the design. JAXA promotes research and development with a focus on the environment and safety, and opens up the possibility of a next-generation aircraft. JAXA has been developing sonic boom reduction technologies as a key to realizing next-generation supersonic passenger aircraft. The feasibility of JAXA's original low sonic boom design concept was successfully validated by the DSEN No. 2 drop test, a flight experiment for the second phase of a project named the Drop Test for the Simplified Evaluation of Non-Symmetrically Distributed Sonic Boom, DSEN, carried out at the S-Range Space Center in Sweden on July of 2015. The experimental aircraft flew as planned, and measured sonic boom signatures showed the effects of sonic boom reductions intended. This is the first ever demonstration that the effect of low boom design, applied to tailor both the front and the aft shockwaves at the same time, was validated via a flight test. By harnessing the cumulative results of this research into supersonic technology, JAXA advances supersonic transport research with industry players, which will eventually lead to contribute to the development of the next generation supersonic passenger aircraft. The DREAMS project, which began in 2012 to better manage growing air traffic, came to a conclusion in 2015. Through technological transfer to private sector corporations, some of the results obtained through the project are being put to use by the Ministry of Internal Affairs and Communications, Fire and Disaster Management Agency and Meteorological Agency, ensuring the project's achievements benefit society. JAXA makes continuous efforts in making proposals for international standards while also achieving further technological transfer to private sector companies. JAXA is working to realize a safe and affluent society using space and the sky. Explore to realize. JAXA.